Hello and good evening after everyone. How you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This is a brand new channel by Unacademy where everything is being taught to you completely in English. This is a special series that I host for you guys every Saturday, and this is where we discuss some really tough Olympiad and advanced level problems. All right. So let me welcome you to this session again. This is the toughest topic of your class 11, 12 syllabus. And today we'll be discussing some really challenging problems on this topic. All right, so before we get started, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, I myself was All India rank 447 and All India rank 182 in the two stages of the IIT JEE exams that I took. I also qualified the NTC Stage 2 as a student, and I was also in the top 1% in the NSCP. Now, so far, I've coached and mentored many students to top ranks and their dream colleges in the offline setups, and now I hope to continue doing that in this online setup. Now, moving forward, how can you guys make sure that you guys are achieving those dream ranks? One great way of doing that is by taking yourselves the Unacademy subscription. So with this subscription, you will get benefits like live classes where you get to interact with your educators. You'll have live polls and leaderboards, and you will also have test series and analysis sessions. Finally, you have live doubt clearing sessions. So after every 3 teaching sessions on an Unacademy Plus course, you have a live doubt clearing session where you can resolve all your doubts, be it about theory or be it about your doubts, problem solving. Okay. So again, with along with all these benefits, Unacademy also provides you the chance to study from the topmost educators all across India. Right. So that's a wonderful opportunity for you guys to explore and make sure your studies are not only going ahead in a very smooth fashion, but going ahead in a very smooth, better than others. So there you are not only preparing, but preparing better than others, getting ahead of the competition. All right. So the first step towards that would be to get yourselves the Unacademy. First step towards getting the subscription would be to install the Unacademy app. Now, the moment you do that, you unlock yourself a lot of free features, and these free features include free courses. All right. And then you have special classes. Okay. And finally, you have quizzes. So you already, just by installing the Unacademy app, you will be able to avail all these features. Now, you can that will give you a taste of what your Unacademy subscription is going to be like. Hello AP, how are you? Okay, now once that is done, once you've got the idea of how the subscription is going to be for you, you can, and whenever you decide to get the plus subscription, this is the steps that you can follow. Go to the plus section of your app, select your goal as IITJ, and you can click on that get subscription button. Now, you can also go for the iconic subscription now. Along with plus, this iconic subscription will take your IITJ preparation to the next level. You'll be allotted some personal coaches from a team of experts. You'll be attending regular IITJ workshops, receiving expert guidelines from time to time, getting a study planner of your own, and having regular test analysis sessions. Trust me, with these benefits and these features, your JEE preparation will actually skyrocket. All right. Now, one another great chance to win this for you guys is to take part in the next Unacademy Combat event, okay? So which will be happening live on the 20th of December, and you can enroll now using the code RD Live. So that's tomorrow, guys. So take part in that, do well, and win yourself some cool prizes. All right. Now, those of you who are following us on the English channel, J English channel of YouTube, can connect with us on the Telegram app using this link. Get this link. Make sure that you receive all the timely notifications of all the lectures and sessions happening on this channel, and you do not miss out on any of those. Okay. Now, okay, so why don't we get started with today's session? I hope you guys are ready with this. All right. So in the last class, we discussed some problems from the book Pathfinder, and then I personally was a little disappointed with the kind of questions that were there. So today I have got more questions from my own collection. Okay, so trust me, they are, I think, more relevant to JEE also, and some really challenging problems which should give you a good practice of all your concepts. Let's see if you are ready for the challenge then. Hi Mahi. Hello Rajesh. How are you guys? So here, if you remember last time we left this question, okay? So there was this one question which I gave you guys more time to think about. And I don't think any one of you has tried. Okay, so I had told you that I'll be discussing the solution of this today. Right. So before we start this solution, I wanted to bring to your attention another very similar kind of a question, which I think you will find slightly easier to approach, and that is why I started. I wanted to start with that. Okay, so let's start with this question. In this question, you've been told a uniform disk of radius capital R is spinning with an angular velocity omega and is carefully placed on a horizontal surface. Now, how long will the disk be rotating on the surface if the friction coefficient is mu? Okay, now the pressure exerted by the disk on the surface can be regarded as uniform. Okay, so I think this is a wonderful question, and this will give you an idea about how to approach the previous problem. So why don't you guys give it a try? Okay, let's see if you guys have figured out how you would have solved this. Hmm. Hmm. So I had told you guys to leave your answers in the comment section, but no, nobody has left any answer. So why don't you guys give this problem a shot? Let's see. Hello, Amod Kumar. How are you? So come on, people, try this problem. This is a problem from another great book, Irodov. A lot of you must have heard of that. This is an Irodov problem. Okay, so I wanted you guys to first try this, and then you will probably have some idea as to how to solve that problem. Okay, so give this a try, and let's see if you guys can figure this out. Okay, all right. So who all are trying? Can you at least let me know? One, you guys should at least let me know. Those of you who are trying, so that I know who all to wait for. Okay, hurry up. This is a wonderful question. This should be easy to solve. Okay, so AP is fine. Yes, of course, these are the tough problems, and that is why we have this session, right? AP. So in this session, we usually do take up the toughest of the problems. So this session is dedicated to toughest of the problems. Okay. All right. So try this, and let's see. Let's see how many of you can figure this out. So think about it. Think about it. Think about how you would have approached this. Okay. And then I will show you the solution. Don't worry about it if you are not able to figure out the answer immediately. That's all right. These are some of the toughest problems on the topic, and rotation being the toughest topic of your entire syllabus. So these are some of the toughest problems that you can encounter in your JEE Advance. Okay, so don't worry. It's all right. It's all right. It's not going to be that easy. Hmm. Okay, let's see. So try it. I'll wait for a couple of minutes. Okay, let's give you 2 more minutes. I think this problem will take 3 to 4 minutes. Okay. So AP has an answer. AP says B. Hmm. Interesting. How about others? Anybody else trying? Does anybody else have an opinion? Okay, so AP at least tried and AP has an answer. We don't know whether that answer is correct or not. Let's wait to hear from other people. What do others think? Okay. So do others agree with AP or does anyone have a different answer? Let's see. Okay, Raj says C. S. Pandey also says C. Okay, so two people against one now. Okay, all right. Hello, Tanya. How are you? Okay, so two people are saying C and one person is saying B. Not agreeing with AP. Okay, so another one not agreeing with AP, and I think correctly so. So, well, the answer is in fact C. Okay, let's see how we would have approached this. So imagine you had a disk. Okay, imagine you have this disk. Now when this is rotating on a, this is the top view, by the way. Okay, so I am drawing the top view. Please note that this uniform disk of radius r is spinning with an angular velocity omega and is carefully placed on a horizontal surface. So the spinning disk has been kept on a horizontal surface like this. It is rotating. You have been asked how long will the disk be rotating if the coefficient of friction is mu. Now what will happen is, okay, all right, never mind. So what will happen is, imagine that it is rotating like this with some omega. Now, because of its rotation, it will feel a friction from the ground. Now, that friction would be kinetic. So what will happen is that if you think about things, so this edge would have felt a friction in this direction. This edge would have felt a friction in this direction. So all these frictions would in fact apply a torque, right? All those frictions on these surfaces, curved surfaces, because of the circular motion. So kinetic friction, will always be opposite to the velocity. So if you take the velocities at any point, so the kinetic frictions would be acting tangentially because the velocities are tangential. The friction will try to oppose that, and this is the way the friction would have acted. Now, if I can judge the torque that this friction provides, then I should be sorted. So for that, what I can do is I can consider a small element of radius r and thickness dr. Okay, so let's do that. Let's consider a small element, okay, of radius small r and some thickness dr. Okay, so imagine this is an element which has a thickness dr and a radius of r. Now you realize that for the entire surface of this, there would be some friction. So friction is always acting like this because the velocities are opposite. Okay, so friction is trying to oppose the velocity. Now for this entire ring segment, what is the kinetic friction? Kinetic friction is mu times n, right? So I can say for the ring segment, considered d of kinetic friction, small kinetic friction acting on that small portion, how much would that be? That would be dm times mu times g. Agreed. Where dm is the mass of that ring element. Okay, if the mass is that, the normal reaction would have been dmg, and dmg into mu, that would have been the kinetic friction. Now, due to this kinetic friction, the torque that would have produced, d tau of kinetic friction would have been dm mu g times. Okay. Now to calculate the total torque, all I need to do is integrate this 0 to capital R, where capital R is the total radius of the disk. Now also I will see that dm would be 2 pi r dr times sigma, where sigma is the mass per unit area. Okay, that is mass per unit area of this disk. Okay, so the area of the circular ring segment would be 2 pi r dr. 2 pi r dr into sigma would have been the mass. That is what dm is. So if I substitute that value, then I will get tau due to kinetic friction. Torque of kinetic friction would be equal to integral of 0 to r. I have 2 pi mu g and then r and sigma and 1 r from here. So r square dr. Okay, so the torque would have been 2 pi mu g sigma would have been taken common, and I would have gotten r cube by 3. Now, I can also say that total mass of this disk m would have been equal to sigma times pi r square. So if I replace this, what I'm getting is 2 mu m g by 3r. Okay, I hope you can see that. All right, once I know the torque, now I know the alpha. So what will be alpha? Alpha would be tau over I. I for a disk is half mr square. So half mr square would have made this 4 by 3 mu g over r. Okay. Now that I know alpha, I know time. Time would have been omega by alpha. Okay, because the final velocity is zero. Omega by alpha would give you 3 omega r over 4 mu g. Okay. So which in fact is option number C. 3 omega r over 4 mu g. Okay. So hi Suraj. So Suraj says, what should I take in bachelor level to become a nuclear engineer? A nuclear engineer. So do you want to say you want to work in nuclear engineer? I don't know. I don't know. I don't know what kind of branch would support nuclear engineer. So there is one branch in IIT Delhi which you can go for. That is called engineering physics. Okay, I think that may help you towards your goal. Okay. So as far as I know and I understand, I think that should be the way. Engineering physics, because that involves that is a study of physics and from an engineering perspective. So I think that would be the first step. I think from there you can go for an MS in engineering in nuclear physics. Okay, I think that should be it. Uh, actually, I haven't heard too much about this, but from what I understand, I think that should be your approach. Okay, so guys, go through the solution and let me know if this made sense to you. Okay, let me know. All right. So if you follow all the logic, it should be simple enough. Okay, and you can let me know if you agree with the solution, or is there any issue that you find? Is there any part of the solution that you did not follow, you did not understand? You can let me know, and I will explain that one more time. Okay. Did you guys follow the solution? Okay. Suraj is saying something else. And mechanical engineer graduate can be aerospace engineer. Yes, yes, absolutely. One of my, in fact, batchmates from IIT Delhi had gone to I think Harvard or Stanford. I don't remember. He either went to Harvard or Stanford for doing his MS in aerospace engineering. Okay, so for aerospace, you need to be a mechanical engineer. Okay, so aerospace is a specialized branch. For nuclear, I don't think. Okay, now that's all right. That's perfectly all right, Suraj. So why don't you try these problems also? Okay, since you seem to enjoy challenging things. Yeah, so one of my batchmates from IIT Delhi had done. I think from Stanford. I remember he studied MS in aerospace engineering. All right. All right. So if there are no issues with this problem, then can we move forward? Can we move forward? Now let's talk about this problem. The problem that we left with the last time. The problem that I told you I want you to think a little bit more. Okay. So what do you think of this then? It's not in my syllabus. What's not in your syllabus? What's not in your syllabus? Rotation. Rotation is not in your syllabus. Okay. So that is strange. Hmm. But this is one topic which IIT JEE advanced people love asking. So if you're planning to crack JEE, then trust me, you need to master this. This one is the differentiator in ranks. Okay. Okay. Anyhow, how about this problem? So come on, people, let's try this problem now. Now, does the previous problem give you slight more perspective about how you could have approached this? Okay. Trust me, I've seen people looking for answer of this on all sorts of places online, but it's not given. Okay. All right, let's try this. Let's see if you can figure this out. Now, as I said, I have got some really challenging problems for you. Now, trust me, these would be probably one of the most difficult problems that you would have seen in rotation. So, if you can figure them out, then trust me, you do not need to bother about rotation problems, at least for JEE. I mean, I'm talking about JEE Advanced, of course. Okay. If you are fine with today's problem discussion, if you follow everything, and if you can figure out how would you approach such tough problems, then trust me, I don't think IIT advanced level problems will bother you ever. Okay. These are some of my personal favorite problems from rotation. Okay. And trust me, advanced. This is the maximum level. I mean, sometimes they like asking some weird questions, like they did in 2016, that disk rotating. Okay, but apart from that, this usually covers your entire advanced rotation. Okay. So, any idea about this then? Please let me know if you are trying this. You can write trying in the chat. If you are trying this problem, then you can write trying in the chat. Okay, so that at least I know who all I'm waiting for. I am waiting for you guys to give this a try before I discuss. Okay, so Tanya is trying. Hmm. Okay. And it's all right if you can't figure this out. Okay. Okay, so try and figure it out. Okay, so I can give you one hint. One way of thinking about this problem is you can try and relate it with this one. Okay, this is a very similar situation. In both the situations, yeah, I know this is tough. In both the situations, the rotating things are slowing down due to friction, right? Okay. So all right. Let me tell you. I mean, this doesn't even have a straightforward solution, so that's going to be a problem. So that's all right. That's all right. But what you need to understand is, if you talk about this uniform disk, okay, so please let me give this disclaimer already. Okay, AP says B. No, B is not the correct answer. Turns out A is the correct answer. Okay. Now, let me give you a disclaimer about this problem already. This will not be solved using a traditional method. This has a sort of different approach. What you need to understand it is that if I consider this, if I consider this kind of a sheet, so which you have been told a uniform square plate is placed like this. Now you will realize if I break this into some circular parts, okay, like this. So imagine some circular parts I am breaking, and these are of radius r and thickness is dr again. So thickness being dr. So what you will realize is if I wanted to calculate the moment of inertia about the axis would have been integral of dmr square, right? And how about the torque due to friction? Torque due to friction would have been mu dmg to r integral this. Okay. So the idea is you realize if this is dmr square and if tau is mu g dmr. So the idea is to understand the dimensional analysis. Okay, the idea is to understand the dimensional analysis. So dimensionally, you realize what is that equation. So dimensionally, you realize I for this kind of an axis would have been parallel axis theorem applied with this axis, right? If this is I1, then you know I is equal to I1 plus MA by root 2 whole square, right? And if this was A, right? So turns out I comes out to be I1, which is MA square over 6 plus MA square over 2. So that would be 2 by 3 MS square, right? Yeah, so that would be 4 by 6 or 2 by 3 MA square. Right, so you realize I is directly proportional to A. Similarly, you can say from here tau will be directly proportional to A. Okay, so that's the idea behind this. What you use is that tau is directly proportional to A and I is directly proportional to A square. To use the dimensional analysis, first of all. Okay. Now what we do is you will realize if I look at this, I can think of this made up of four smaller parts like this. Okay, so imagine that is what I am doing. For my second part, what I am doing is if I had this, now I will think of this from this axis, okay, as made up of four smaller parts. Okay, four smaller parts of side A by 2 each. So if the moment of inertia of this is I dash, this is I dash, this is I dash, this is I dash. From dimensional analysis, I can say, because of this fact, I can say I dash would be equal to I by 4. Why? Because if the sides have become half, the moment of inertia would become by 4. Agreed. And if tau dash is the torque experienced by this part, okay, if tau dash is the torque experienced by this part, then can I say because of this dimensional analysis, tau dash would be equal to tau by 2 because the sides have become half and tau was directly proportional to the side of the square plate. So that is all my idea is going to be. For this entire thing, the net torque would be 4 tau and the net I moment of inertia would be 4 I dash. So I can say alpha dash. So for this plate, alpha dash would have been equal to tau dash over I dash. Okay. So that would become alpha dash becomes equal to I. Okay, so tau over torque over this. So tau over 2 and I over 4. Would you realize this alpha dash is 2 times alpha, where alpha is the retardation here. So this was rotating like this, omega, and the retardation was alpha. So the retardation of this would be 2 times alpha dash. Okay, the rate of retardation is twice. So the time taken for retardation obviously will be half. Okay, that is how A is the correct answer. Okay, I don't know how much sense does this make to you guys, but trust me, this is the only way to solve this. I told you last time also the solution is very tricky. Okay, this is the only way to solve this. Oh, you could have written this also for the entire plate. The net torque becomes 4 tau dash, and the net moment of inertia becomes 4 I dash. Okay, so let's get this out of the way. Okay, I mean you can see here what the idea is that you can see if this is how this was related. Okay, the torque, the moment of inertia is coming out to be proportional to A square because it had integral of R square in there. Similarly, I can say if torque has an integral of R, if torque has an integral of R in it, like this, so when you get the final expression of torque, it would be directly proportional to the dimension, which you can see here also in the previous question. In the previous question also you can see that when you see the torque here came out to be proportional to R. right? So it is proportional to the dimension and directly proportional to the radius. That is the idea. And here also, you know that moment of inertia is proportional to r square. The moment of inertia is proportional to r square, and the torque is proportional to r. Okay. Okay. So did I? If I made it simple, then I'm glad. I'm glad because this is the only way to solve this. This is an Olympiad level kind of a problem. This is a typical Olympiad problem. I don't think JEE would like to ask this. This is Olympiad level. Okay. And I will tell you that even if you tried looking for an answer for this online, I mean, you would have had a tough time. Okay. So I hope you guys followed the logic. So demonstrably, with the help of these expressions, we tried to relate the moment of inertia and the torque of half-sized plates. If I had a square sheet of A by A, then for a half-size sheet, the moment of inertia would have become 1/4 and the torque would have become half. Okay, so that is the idea. So if the moment of inertia becomes 1/4, torque becomes half, so angular retardation will become double. So therefore, the time for retardation would be halved again. Okay. I hope you know that time would be omega over alpha. That is why if omega remains the same and alpha is getting doubled, so time will become half. Okay. All right. How about another challenging problem for you guys? So here is yet another challenging problem that I have for you. This problem tells you that a cylinder of mass m and radius capital R is rotated with a uniform v groove with a constant angular velocity omega. You can see the figure. Between the cylinder and each surface is mu. Now the torque required to keep the cylinder rotating is. Okay, so try this. To try this quickly, let's see. Let's see if you guys can figure this out. Okay. So this is not that difficult, but it is tricky as hell. This is also very tricky. Okay, so my laptop is not charging, so let me just check for that. Till then, you guys can try this problem. Okay, seems fine now. All right. So others says D. Okay. Hello, nothing peace. How are you? So others, you must have solved this then. Hmm. Interesting. I think D may be the correct answer. I think D may be the correct answer if I remember it right. All right. So great. Well done, Adarsh. How about this? Have you solved this? Have you solved this Olympiad special? Okay. All right. All right. So you can try this also, by the way, and try and figure it out. All right. For this, I think D was the correct answer. This is not that simple as it looks, though. So D might be the correct answer. So let's talk about the solution a bit. Let's talk about the solution. So first, what we'll do is we'll draw an FBD for this. So let's talk about all the forces that are acting on this. So you definitely have your mg. Okay, so mg is going from here, and then you have some n. So let's say from here you have some n1, and from here you have some n2. Okay. All right. So what is the temperature in Delhi? So temperature in Delhi, I haven't checked. Let me just see it in my phone. I think it's very less from what I can feel. So right now, I think it's 11 degrees Celsius. Yeah, it's 11 degrees Celsius right now. I had a feeling it would be around 10. All right. So, but I'm sitting all cozy in my room with my heater on, so I'm not feeling it. All right. Now, due to rotation, you will realize there will be a kinetic friction which will act like this, and then there will be a kinetic friction which will act like this. Right. So I hope, yeah, it's pretty cool. I love Delhi winters. I love Delhi winters. All right. Here it's 37. So where are you? Where are you? Hmm. Chennai. Okay. All right. Yeah, yeah. So Chennai is hot. I love Delhi winters. It's awesome. Amazing. I mean that's why I yeah, yeah. I never shifted to wanted to shift to Bangalore or Mumbai because I would miss winters too much. Okay, so yeah. Thankfully in this lockdown I can do all my teaching from home without having to shift anywhere. All right, so let's try this. How we would have solved this. So first of all, you will notice that this rotating cylinder is in translatory equilibrium, right? So I can say that since the cylinder is in translatory equilibrium, so what I can say is that the net forces acting in the x and the y directions would be zero, right? So what are the forces acting in the y direction? So let's see. Let's see. One, this F1 would have a component in the y direction. This F2 would have a component in the y direction. Both the ends would have a component in the y direction, and mg. So I can say from here that n1 plus n2. So n1 cos 45 plus n2 cos 45 plus f1 cos 45 would be equal to mg plus f2 cos 45. Right? Okay. Next, this is for y direction. For x direction, I will again have to see that f1 plus f2 that should be equal to n1 minus n2. So all the right hand side forces should be equal to left hand side forces. So I can say n1 sine 45. Again, sine cos doesn't really matter. That's why I'm writing anything as sine and anything as cos because the angle is 45. Okay. So don't worry. Nahi, sir, this will not be cos, this will be sine, and that was not cos, that was sine. This will not be sine, this will be cos. Don't worry about it so much because the angle is 45 degrees. That is why I'm not bothering. Okay. Okay. 45 plus f1 again cos 45 sine 45 whatever you want to write f2 cos 45. So this will be my equation for the x direction, right? Now I also know that both the frictions acting are kinetic in nature. So I also know F1 would be equal to mu N1 and F2 equals mu N2. Correct. So if I substitute all these values here, let's see what I'm getting. From here, I will be getting that N1. Okay, all these would have gotten cancelled. N1 equals N2 plus mu 2 and here plus mu N1. What I'm getting from here is that N1 equals 1 plus mu over 1 minus mu times N2. All right, now I can substitute these values and this value in this expression. Find the values of n1 and n2. And once I have n1 and n2, I know f1 and f2. Okay. Do you guys want to see the complete solution or is this good enough? Okay, so I don't know. Let me know. Do you want me to find the final answer? Okay. So let's see. What I can do is I can multiply the entire side by root 2. So I can get rid of these and write root 2 here. Then I would have gotten n1 plus n2 plus f1 which is mu n1 That's equals root 2 mg. Right. Okay, Shivam says today I wanted to ask doubts from you on Plus, but you came on YouTube. Today I did not have any session on the Plus today. Okay, I have a session tomorrow on Plus. You can come tomorrow and ask your doubts there. Okay, don't worry about it. Don't worry. Okay, now what do we have here? So let's start making some substitutions. Right, let's start making some substitutions. And I hate changing my page when I have these big expressions involved because I always make the mistake of, so this is n1 1 plus mu plus n2 1 minus mu is root 2 mg. Okay, I hope I got that right. Okay, so this will be n1 1 plus mu, n2 1 minus mu. Okay, and n1 was this. Get this. Okay. So next, I will substitute n1 as n2 times 1 plus whole square over 1 minus a plus 1 minus mu is root 2 mg. Okay, let's take out n2 common. If I take n2 common, then I have 1 plus mu whole square plus 1 minus mu whole square again, which would be equal to root 2 mg 1 minus mu. So let's see what I'm getting. N2 I'm getting as root 2 mg 1 minus mu, but now this would have been 2 plus 2 mu square, right? Yeah, 2 1 plus square, right? So I'm getting this as mg 1 minus mu over root 2 1 plus mu. Okay. Shivam was saying, so today I have practiced 15 questions from HCV and NCRT combined. So can I go and study chemistry or you want me to practice more? No, I think if you're feeling comfortable about your physics, then you can go and study chemistry. I never told you that you should be studying physics all the time. Okay. All right. I think 15 questions a day is good enough. See, you have three subjects. If you're solving 15 questions a day daily for all those subjects, I think that's around roughly around 50 questions a day, right? I think that much practice should be good enough. You're getting that practice daily. Okay. Now N1 of course would be it was 1 plus mu 1, so N1 would be m root plus mu square. Now that I have N1 and N2 both, I know the net torque due to friction, tau due to friction would be F1 plus F2 times R, and that would be mu R N1 plus N2. That becomes mu R N1 plus N2 is mg over root 2 plus mu square. I can take common, and inside I'll have 1 plus mu plus 1 minus cancel. And finally, yes, that is what I'm getting. Root 2 mu mgr over 1 plus mu square. Okay, so there you have it. That is the torque due to friction, and that is the torque that is required to keep the cylinder rotating. Okay, so that's the long solution, but it's just a bit of calculation. As I said, most of your challenging problems will require a lot of calculations. Okay, so for this kind of the level of this problem is pretty difficult. Okay, so don't worry about it. My physics sir said physics marks decide your rank. Okay, all right. I think he forgot that maths and chemistry marks also count. All right. So what are you preparing for? Nothing, please. Are you preparing for JEE or NEET? First of all, let me talk about that. So yes, here we have it. What happened to R? There was some R missing. I should have R. This is dimensionally incorrect, right? This is dimensionally incorrect. So R, of course, should have been there. Exactly. Shivam is absolutely right. Shivam is absolutely right. The maths teacher would have told you that maths decides the rank, and the chemistry teacher would have told you that chemistry decides the rank. Okay. So in my experience, let me tell you that chemistry is the most scoring or easily scoring at least. So what happens is that if you are not scoring well in chemistry, you are losing out on the rank. But all the good students, I think, will end up scoring well in chemistry. Now the differentiation will come from physics and maths, and out of which I think maths is the least scoring in my experience. It is the least scoring, at least. So this would count a lot, and this is also a differentiator. So every subject has its own importance. Every subject has its own importance. All right, you can't just say okay, this subject is more important than others. All the subjects are important. See, the topper would get around 90% marks. You know that whoever is topping IIT JEE these days, mains or advanced, they get around 90% marks. So 90% marks you cannot get without having a good balance of all three. Okay, kya, what? So, okay, nothing. We say JEE main, yes, sir. Shivam says, sir, ये वाला PPT आपके साथ प्लस पे कि मैं जाऊं. नहीं, इसमें सिर्फ यही प्रॉब्लम आपने प्लस पे किया था. अदर प्रॉब्लम्स वुड बी न्यू. एनीवेज, हाँ, बट यू कैन गो. So please take that these sessions in morning, as रात के वक्त दिमाग नहीं चलता ज़्यादा. I feel maths is easy to score, but chemistry is tough. So yeah, it's different for all. But so as I was saying, the toppers usually get up to 90% scores, right? So think about it. If you're looking for a great rank, you want a good balance of all the three subjects. You cannot say one subject is more important and this decides your rank or that decides your rank. I personally don't believe it. Though, though I used to be really good at physics, of course. Okay. And will you take sessions in morning? Uh, what time in morning do you want? I don't know. I thought most of the students have classes in the mornings. Okay, so most of the students I thought would have classes in the mornings. Especially like I thought most of the students have their classes in morning, especially till like 2 or 3. And that is why I prefer taking night sessions. Yes, I did. Yes, I did. I 4 a.m. Okay, yeah. So why not? Why not? That sounds like a wonderful idea. Let me think about it. No, let me think about it. Yeah, I know. I know. I know. Very good. So somebody would last year. I mean, a few months back, I think some people requested me, sir, take classes till 11 and 12 in night, one at night, because we study till late at night. So yes, so that is the reason why I'm taking these classes at this hour, Noman, because most of the students have their school classes in the mornings. Okay, and I am not that early an riser. Hey Shivam, I know at 4 a.m. Rohit sir will be streaming and you would be sleeping. Yes. No. I think it will be the other way around. I'll be sleeping घोड़े बेच के. Anyhow, how about this? अच्छा ये वाला भी किया था. Okay, तो तुम कल के सेशन में आ जाना फिर. Okay. Hmm. Don't worry. It's all right. It's all right. You try and attend the session tomorrow. Okay. Tomorrow I'll have some new problem for that session. Okay. So how about this one? This is another interesting problem. So this problem is also in Erodo. I have picked it up from elsewhere though. Okay, bye bye. Take care. Good night to you. All right, a cylinder of radius r and weight w with an initial counterclockwise angular velocity omega naught is placed in the corner formed by the floor and the vertical wall, denoting by mu the coefficient of friction between the cylinder and the wall and the floor. Derive an expression for time required for the cylinder to come to rest. So, शिवम says शुभ रात्रि to you, and Pallab says sir क्या 2 year preparation में top 100 में आना possible? लोग कहते हैं 9th से start करना होता है. Okay, so that's a tough one to answer. See, possible है, definitely possible है. Okay, I won't say possible नहीं है, because 2 years is a good enough time. But also, if you talk about practically, because most of the students these days start their preparation in 9th, so the trend has been that from what I have seen in the last few years, I think most of the students that are getting ranks in top 100 are the ones who started their preparations in 9th. Okay. I did over 100 problems in rotational dynamics, only 40 were correct. Oh, yeah. So this is a tough topic. It's all right. Okay, Pallab. So it would be very difficult. It is definitely possible, but would be very difficult because it's a competitive exam, right? Rohit sir, I feel as the cylinder has to stop and not rebound back, it would even slip at that place after touching the wall. Yeah, so it's just slipping. It's just going on slipping in its position. It's not rebounding. It's not rebounding. See, it just has a spin. It just has a spin. It has no translational velocity. Okay. So you also was dropper and under 150 you are great, sir. Okay. That time people never started studying from class 9th. Trust me. Okay, that time people never started their preparation so early. I took it like way back. I took my JEE way back. Back then, yes, people had start preparing from 11th, definitely. I think that was the trend that people used to prepare for 2 years, 11th and 12th. So I prepared for 1 year, and I don't know, I would have managed a top 100 rank, so to say, but I just made some mistakes in my paper. Preparation wise, I was sorted for a top 100 rank. That was never an issue. Just that I made some silly mistakes in my paper, so that is why I'm saying, that is why I was telling Pallab, it is possible, it is definitely possible if you have the right acumen and if you are ready to work hard, there is no reason why you can't do it. But practically, it's going to be a little difficult. Okay, sir, इसका B है ना? नहीं, इसका B नहीं है. नहीं है इसका B. B नहीं है भैया, इतना आसान नहीं है. There is a reason I'm discussing these problems. These are some of the toughest problems. Okay. Sir, let's solve this interesting problem now. Okay, I thought you guys were trying this. Okay, so I will solve it. I will do the honors. So first of all, before doing anything, let's take a look at the FBD. Okay, let's take a look at the FBD. What are all the forces that are acting? So one, I have mg acting on this. You will find this problem in Iridov also. Okay, so Shivam says, sir, 10 मिनट की जल्दी भारी पड़ गई, आपको अंडर 100 नहीं मिला, अब क्या करें? होता है ऐसा कभी हो जाता है. ठीक है. देन अगेन आई ऑल्सो बिलीव यार किस्मत की बात होती है. अगर आना होता तो आ जाता, शायद किस्मत में ही नहीं था. थोड़ा सा लक भी होता है यार. यहाँ से कुछ N1 मान लेते हैं, यहाँ से लेट्स अज्यूम कुछ N2 लग रहा है. And because of this spin, there would be two frictions acting, right? One kinetic friction acting like this, let's call that F2, and one kinetic friction acting like this, let's call that F1. You guys agree? These will be the 5 forces acting on this cylinder. These are the 5 forces that are acting on the cylinder. Mg, normal reactions from both the walls. both the frictions because there is slipping with respect to both the surfaces. Now, this cylinder is in equilibrium, okay, translatory equilibrium. So what I can say is I can again write equations from the translatory equilibrium, and I'll say since the cylinder is in translatory equilibrium, okay, so that's weird, है ना? एक मिनट यार, कुछ घंटी वंटी बज रही है, मुझे ही देखना पड़ेगा. So I can write mg equals n1 plus f2, mg equals n1 plus f2. That would be my first equation. Then I would have had second equation f2 equals f1, okay, for equilibrium in x direction. And then of course both are sliding frictions, so f1 would be mu n1 and f2 would be mu n2. Correct. Now from all these equations, no, that's what I did not order coffee at this hour. Let me just check it out. You guys try and solve this from here. Okay, and I'll be back in 1 minute. Okay. All right. So now let's get ahead and solve this. Okay. Let's see. What do I have from here? From these two equations, I can find out both n1 and n2s, right? Okay. So I can write that from here. Okay, I can write mu n1, which is f equals n2. Okay. So f2 is mu square n1, right? So if I substitute these values here, then I get mg plus equals n1 plus f2, which is mu square n1. So from here I'm getting n1 equals mg over 1 plus mu square. Okay, so I got the value of n1. Okay, so what Norman says, sir, your माइक ऑर्डर किया था. हाँ, माइक है मेरे पास एक्चुअली. नहीं, माइक पहले से था, वो आई हैड टू रिमूव इट व्हाइल गोइंग आउट. ओके. Anyhow, so this is n1. Okay, how about n2? So from here I can also figure out n2. N2 was mu times n1. So n2 comes out to be mu mg over 1 plus mu square. Right. So now that I have both n1 and n2, I can find out the torque due to those frictions. Now if I take the torques about C, so taking the torques about C, I will get torque due to both the frictions. So now I can say taking torques about C, the tau would be equal to f1 plus f2r, and that should be equal to this is a cylinder. Okay, so mr square by 2 into alpha. Correct. So now let's just substitute these values. So f1 plus f2, you will realize from here would be mu n1 or mu plus square n1 equals mr square by 2 alpha. Okay, so let's just add another page here. All the solutions are pretty long. Can't help it. That happens. So let's see. So I have mu times 1 plus mu times n1, mu times 1 plus mu times 1 equals mr square by 2 alpha. And n1 was mg over 1 plus mu square. Okay, so let's now do all the substitutions. Mu times 1 plus mu times mg over 1 plus mu square. This equals mr square by 2 alpha. So gets cancelled. I have into r also, no? 1 F2 into R. Yes. This would get cancelled. So alpha is coming out to be 2 mu 1 plus mu G over R times 1 plus mu square. Okay, so now you know what is the time required in which the thing will stop. So time, omega naught minus 0 equals alpha t. So we can write t equals omega naught over alpha. So that would be omega naught R 1 plus mu square over 2 times mu 1 plus mu times. Yeah, that should be the answer. Does that look dimensionally correct? Yeah, it does look dimensionally correct. Okay. All right. So this is how you would have solved that problem. Let's see if we have this in any of our options. So this is it. You know what, R into 1 plus mu square over mu 2 mu G. Very long. Yes, but that is the one. Okay. So D is the right answer, by the way. Again, one of the toughest problems. This is also a problem in Erudov. I think you will find this problem in Erudov, and I have taken this problem from some other book though, and that is also one of the toughest books. Okay. All right, Shivam. Bye bye to you. Okay. All right. So think about this. Think about this. We drew the FPD, then we wrote the equations for translatory equilibrium, and then with the help of because these are kinetic frictions, so I could write F1 equals N1 mu, F2 equals N2 mu. With the help of these equations, we try to figure out the values of N1 and N2. Once I knew the values of N1 and N2, I could find the values of friction. Then I could take torques about the center of mass and determine the alpha, the angular retardation. Once I knew the angular retardation, I can find the answer. So why are Unacademy JEE English teachers switching to JEE 24/7? Okay, so I don't know. Are you talking about, who are you talking about? I have no idea about that. So are you talking about Abhinav sir? Okay, I don't know. I know there must be a requirement. I have no idea. Okay, so I don't know. I don't know. Maybe there must be some kind of requirement there. Okay, I don't know. Hmm. All right. Anyhow, I hope you guys followed the solution. Let's focus on the problems here. Okay, so 2+ batches are already over, Noman, and I'll be starting new batches next week. 2 new batches next week. Okay. All right. So if you guys followed the solution, then let me know if there is any part of the solution that you do not understand or do not follow, then also you can let me know. And if there is no problem with the solution, then let's move on to the next challenging problem. Okay. Year-long batches. So I have no idea about that. We have spoken to the team. I think it was because we guys started this channel so late. So maybe next year. I don't know. I don't know. We'll have to see about that. Okay. Right now, I cannot commit to that. I will have to discuss that with the team. Okay. All right. So let's move forward then. So here is another problem. This is again a wonderful problem from Erudov. I think I really like some of the problems of Erudov. So that is why I have taken some problems from there. Okay, so let's try this one. So this says a uniform solid cylinder of radius point 15 centimeters or 0.15 meter rolls over a horizontal plane passing through an inclined plane forming an angle alpha, which is cos inverse of 6 by 7 to the horizontal. You can see the figure. Find the maximum value of the velocity v naught, which still permits the cylinder to roll onto the inclined section without a jump. Okay, sliding can be assumed to be absent. All right. So what do you think will be the answer for this? Let's try this. As I said, I thought there were better rotation problems in Erodo than in Pathfinder, I think, and other sources also, couple of other sources. So I've got a couple of other sources also for really challenging problems. Okay, we will come to that. We will come to that. Let's try and figure out this one first. Now, this is a problem which is very similar to a problem that was asked in JEE Advanced, by the way. JEE Advanced asked a very similar problem. Okay, so JEE Advanced, what they did was they said that this cylinder is kept on the edge of a table, and from the edge of the table, it starts to roll. When will it lose contact? After turning, how much will it lose contact? So the idea behind solving this problem would be the same as the idea behind that problem. Okay, all right. So give it a try. Give it a try. Let's see if we can figure this out. Yeah, let's see. So any ideas as to how you will solve this? Anyone? Okay. Anyone having any ideas? Let me know how you will solve this. Okay, again, if you've solved your previous year JEE advanced questions, then you would be able to solve this. So AP says A. Okay, okay. I think AP is correct. Yes. If I remember correctly, A is the correct answer. So let's try. So here, what you have been told is almost there. Okay, okay, Norman. So I'll wait for you then. Okay, because Tanya is also trying. So let's wait for Tanya and Norman. Okay. Tanya also says A. Okay, all right. Okay, how about you, Norman? How about you? Did you figure it out? Okay. So A is the correct answer, by the way. Okay, I didn't get the answer. Okay, that's absolutely fine. So let's see what you would have done. what you would have done. Okay, so imagine that's absolutely all right. Okay, so let's imagine your cylinder is like this, and now if it when it starts to roll down this, when it starts to roll down the edge, imagine when it has rolled down by an angle theta. So when it has rolled by an angle theta, so if you realize the art of attempting JEE videos also need more videos like that, sir. Bit motivational videos also. Absolutely, absolutely. So don't worry about it, AP. I will be coming out with those kind of videos once a week. So I already take this special session, and I'll be taking one more session for tips and tricks for last minute JEE things. Okay. So all right. Let's see. So imagine if it has rotated by some angle theta, then what is the new omega? Can I tell you the omega? So let's imagine right now omega naught was, let's say, V naught over R. Okay. And if I apply energy conservation, so I can say when cylinder has turned cylinder has turned by theta. So its center of mass would have come down by a height of R1 minus cos theta. So what I can say is mg R1 minus cos theta. This would be the energy, potential energy loss. This should have been equal to gain in kinetic energy. So gain in kinetic energy is half of 3 by 2 mr square. So that is, I am writing about half I about the instantaneous axis of rotation into omega square minus omega naught square. Correct. Okay. Now the maximum angle which it can rotate without jumping off. So I can also write the equation for that. So for just for jumping off jumping off, what will happen is, see, as the omega is gaining, if you draw the FBD of the cylinder, what will happen is, so let's try and see it here. Imagine here at some point when the cylinder is over here at the edge, okay, when the cylinder is over here at the edge, now what is happening is that it will feel a centrifugal force and it will feel an mg. Imagine when it has turned by an angle theta, so there will be one mg that will be acting here, and we can apply a centrifugal force to its TM, which would be like this, m omega square r. Okay, because this will be the instantaneous point of rotation. So about this, I can say, n will be zero. Absolutely, n will be zero. So in this direction, I can say that mg cos theta would be equal to m omega square r. Agreed. So yes, that would be the condition for just jumping off. I can say that mg cos theta equal to m omega square r. Correct. Now let's just remove this r, and what I can do is I can write 1 minus cos theta equals 3 by 4 m omega square r. I would have gotten, instead of that I'll write mg cos theta minus 3 by 4 m omega naught square r. Correct. So from here, what I realize is that if I get rid of all the m's also, what I realize is omega naught square r e by 4 equals 7 by 4 e cos theta minus g, right? Okay. Now, what you need to realize is, all you need to do is that uh, substitute this value, okay, of omega e naught over r. You substitute that value of omega, and cos theta was given to you as 6 by 7. So you will realize 3 by 4 v naught square over r would be equal to, here you would have had this to g into 6 by 7, okay, minus, so you have you would have had 1 by 2. 3 by 2 minus 1, so 1 by 2. So from here, I'm getting 3 by 4 V naught square over R equals G by 2. Okay, so what I'm getting as V naught square is, let's just write the final result here. V naught square equals, naught square equals 2RG over 3. 2RG over 3. Okay. Now let's just substitute the values. So this is 2 into 0.15 into 10 over 3. So this and goes, this is 5 and this is 1. So V naught square is 1, so V naught comes out to be 1 indeed. So Vasya says, sir, I have another work. I will catch the recorded section later today. All right, no problem, no problem. Okay, no problem. So I hope you guys followed this solution though. Okay, I hope everybody followed this solution. So you used energy conservation to figure out the omega at any theta, and then you realize that the condition for just jumping off would be that the centrifugal force would have been equal to the mg component. Okay, for just jumping off. Now using that, if that does not happen till our alpha angle, then our cylinder will roll down without jumping. Okay, because that's the angle by which our cylinder needs to turn to reach the lower incline. If it can successfully turn by an angle of alpha without jumping off, then it will easily roll down. Okay, so that's the idea. ID sir, I just don't know why people are still going to. Okay, okay, because there are. So, all right. Thank you so much, Noman, for the compliment. All right. Now this is yet another very interesting problem. Okay, so let's see if you can figure this one out. So this says a small clamp of mass small m is attached at B. So here is the point B. Okay. Now to a hoop of mass capital M. So this is a hoop or a ring of mass capital M. Now the system is released from rest when theta is 0. So at theta equals 0, system is given just a slight bit of push. And it starts to roll without sliding. Knowing that capital M equals 3m, determine the angular acceleration of the hoop when theta is 90. Okay, what will be the angular acceleration of the hoop when theta is 90? So this is capital R. Okay, let this to be capital R, the radius of the hoop. So try this, guys. And this would be the last problem, I think. This is another nice problem. This is one of the most challenging problems that I wanted to discuss, but I will maybe give you those as homework. You can try them later. Okay, this is the last problem. I think we don't have too much time. We won't be having time to discuss two more problems. How about this? This is something that you usually don't see. That is why I've brought you this. This is a case, as I don't know if you've seen my lectures. I've told you that when you are analyzing things which have the geometrical centers coinciding with the center of mass, then the analysis is easy. This is a case where the center of mass is off the geometrical center. So here you have a new kind of situation, which makes this very interesting. So try and let's see if you can figure this out. Okay. Let's see if you guys can figure this one out. So any ideas about this? So give it a try, give it an honest try, and let's see. See what you think. Okay. So give it a shot and let's see if you can figure this very, very tricky situation. Okay. Let's see. No one. Okay. Well, you know what? I would like you guys to actually give this some honest try. I would have wanted to see some attempts. Okay, so what we will do is I want you to try this and I want you to think about this. There is a very common mistake that you'll do here. Okay. So I will tell you the answer. Okay, the answer actually is B. And let's see how many of you can figure that out. Okay. So I think you can take these problems as homework. You can try them and we will discuss them in the next class. Okay. This is a wonderful, wonderful problem. And then I had another problem which seems very complicated. Okay, it says a uniform sphere of radius r rolls down an incline shown. Okay, no, 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 not B. B is the correct answer to that. So this problem says a uniform sphere of radius small r rolls down an incline shown without slipping. It hits the horizontal surface and after slipping for a while, it starts rolling again. Assuming that this sphere does not bounce as it hits the horizontal surface, determine its angular velocity after it has resumed rolling. Okay, so that's another great problem, which seems very very tough, but trust me, the solution for this is very easy. Okay, so this is also something that I would want you guys to try. And when you figured it out, you can leave your answers in the comment section. Okay, so A, S Pandey is absolutely right, by the way. So the answer for this is A, in fact. Okay, all right. And then there is another amazing, amazing problem. You can think about this. This is going to be challenging, and unfortunately enough, I don't have the answer for this. I don't have the options for this. So you can leave the answers for this problem. Again, consider this your challenge problem. Wonderful problem, wonderful, wonderful problem. Let's see how many of you are able to figure it out. So the problem says that a 30-gram bullet fired with the horizontal velocity of 350 meter per second into the 8 kg of wooden beam. So here you have a wooden beam AB and a bullet moving with 350 meter per second strikes into it. Okay. Now here comes the interesting part. The beam is suspended from a collar of negligible mass that can slide along a horizontal rod. So here, this end, from where the beam is suspended, is free to move frictionlessly. Okay, and of course the thing can rotate about this also, and this can freely slide over that horizontal rod. Now, neglecting the friction between the collar and the rod, determine the maximum angle of rotation of the beam during its subsequent motion. That should be very, very interesting. So try this again, homework. Leave your answers in the comment section. Let me know what you think about the approach of this, and we will try and discuss that in the next class. Okay, so that is it from my side for now, guys. This is where I would like to wrap up today's session. And before I leave you, let me remind you that if you haven't gotten your Unacademy subscriptions, what are you guys waiting for? Stop wasting time. Get the subscription fast. And this is how you do it. Go to the plus section of the app. You select your goal as IITJ and you click on that get subscription button. Okay. Now, when redirected to the payment page, don't forget to use the code RDLIFE. And when you click on proceed to pay, you will be getting a lot of opportunities. 1.2, no. No, AP, no, it's not going to be that easy. Okay, so no, no. Again, when you click on proceed to pay, then you can choose from a lot of no cost EMI options. Now you can also opt for the iconic subscription. It will take your ITG preparation to the next level. You'll be allotted personal coaches. You will be attending regular ITG workshops, receiving expert guidelines, getting a study planner, and getting regular test analysis sessions. Okay. Now you should also remember to compete in the next Unacademy combat event, which is happening tomorrow. In fact, you can enroll now using the code RD Live and do well in that. Good luck for all those who are trying to compete there. Do well and win yourself some really cool prizes. Now, if you like today's session now, do not forget to press that like button and also share it with more and more people. So trust me, we are discussing some of the toughest problems on a rotation. You will never not find this kind of a discussion easily on YouTube or any online sources for that matter. So make sure other people are getting the challenge. So challenge your friends, show them these problems, ask them to try these, and let's spread the joy of solving some really challenging problems. If you're new to this channel, don't forget to subscribe, and if don't forget to press the bell icon. PDF of all these slides using today's just will be available for download very, very soon. Those of you who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link of JEE English, so that you are always receiving timely notifications from all the sessions and lectures happening on this channel. Hi, unsub. So you are a little late, unsub. So we are just about to wrap up today's discussion. Okay, you can watch it, record it. Okay, and then there are 3 challenge problems that I have left for you guys to try on your own, which we will discuss next week. Okay. All right. So that is my time for today, guys. I will take your leave now. And before I leave you, let me remind you, this is my code RD Live. So one last time. So if you plan to get your Unacademy subscriptions, you can use this code and get a 10% off on all your subscription fees. Okay. So hello, hello Anya Prakash. So a lot of you guys are late. All right. So Ansab says, sir, can start NCRT line by line series. Okay, what's that supposed to mean? NCRT line by line series, what's that supposed to mean? Do you want us to be discussing NCRT? Okay, I think don't I will see what I can do about that. Okay, answer. I'll definitely give it a thought, and I'll have to discuss it with the team because it is not only my decision to make. Okay, so I'll take up your suggestion, answer, and let's see what we can do. NCRT line by line is something physics galaxy does. Oh, okay, okay. All right. Let's see. I will convey your input to the Unacademy team, and let's see. Find points in NCRT or something, I guess. All right. Anyways, both you guys, I'm so sorry about this, but you are a little late. We are just wrapping up the session. But you know what? Go through the recorded session. There were some really, really challenging problems that we discussed today. And 3 challenging problems I'm leaving for you guys to try on your own. Okay. So try them. Leave your thoughts in the comment section. Sir, many Hindi channels do it. Okay. As I said, answer, but it's not entirely my call to take. So I will convey your input to the Unacademy team, and let's see what they have to think about this. Okay. All right. So with that, let me take your leave, and I'll see you guys with the next session on the next Saturday. Okay. Don't forget to join me at 8:30. Okay. So that's the time. In case you guys are not aware, we host these sessions at 8:30 from 8:30 to 10 every Saturday. Okay, so if you want to attend these sessions, that is the time. All right. So I'll see you guys next Saturday with this kind of session then. And take care and keep studying hard, keep practicing. Okay. Do not waste time. I can't tell you that enough. All right. Bye bye.